Check one. Check one. Right. Hello, everybody. Back again with our night session, right? The question night session. Uh, we were doing on 2019 O-level paper, but in between, I wanted to finish the support seminar paper as well. Support seminar paper. 2023. Never 24. 24, 25 O-level support seminar paper. Actually speaking, for this year, the real standard support seminar is not released. And every year there's a support seminar paper released from the ministry. That exact support seminar is not released, but this support seminar, it's a collection of so many support seminar questions. And this is not the standard support seminar that is released from the ministry. Usually ministry releases support seminar papers before your O-level. By now they should have released. So it's not yet released, which means they are not planning most of the time. They are not planning on releasing one. But however, whatever the support seminar we got, it's a collection of so many support seminar questions. If you look at the question, those are already previous questions. So it's a collection of all the previous support seminar questions together, but a pattern balanced paper. That's why as soon as I saw the paper, I sent it to the group and I told we'll discuss it. A good paper to touch so many sections. Hurry. Before we start, confirm me from your end. Can you all hear me properly? Can hear? Is all the duos perfect? All perfect. 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 Right. One more point I want to tell. Don't think that support seminar paper is a guest paper. Don't go to your exam based on guess mind. At the exam, anything can come. Anything can turn up. So never go to your final exam, a public exam, based on just some guessing. Anything can happen during that time. I'm telling for all this, don't guessing. Study everything that you can. Study whatever the things that you can. Put it to the brain and go. You go like whatever the ball they put you, you bet it in all the styles that you can. Go like that. Don't think upset. Don't go like that. Go with a strength that whatever they give you, whatever the examiner gives you, you have the strength to fight against. Go with kind of a motivation. Now we have 1 month. We have 1 month. Guaranteed you can build up that motivation. You can guaranteed make a point that you go to the exam with whatever they give, you can fight. Such a mindset you can come. Basic logic is work every day. That's it. Don't waste a single minute. That's the basic logic behind everything. I'll start. First, what I will do is, I will finish off question 20 to 40. Today we'll finish off 20 to 40. Right? Last 20 questions. That has some bigger things to discuss. So we'll finish question 20 to 40. After that, I'll go to the first part. Right? After that, today we'll finish off 20 to 40. After that, I'll go to the first part. Now, those who are not done, try to do before me. Try to do before me. I have already sent the paper to the group as well. I've already sent the paper to the group. Hurry, ne? Hurry, right. Without wasting time, Onnalamai will start the paper. Take question number 20. We are going from 20 to 40. Take question number 20. Take question number 20. Out of the following reaction, which is an endothermic reaction? Which is an endothermic reaction? Heat absorb. Reaction of sodium hydroxide with HCl. That is acid-base reaction. Remember, acid-base reactions are exothermic. Acid-base reactions are exothermic. HCl, sodium hydroxide, onnalamide, that is exo. Second one, dissolving sodium hydroxide with water. You dissolve a base in water. You dissolve an acid in water. Guaranteed exothermic. Base dissolution in water, acid dissolution in water, both are exothermic. Dissolving sodium hydroxide with water, exothermic. Dissolving sulfuric acid in water, exothermic. Both of them are exothermic. Your reviews now, you're right. I told you this is a good paper to discuss so many sections. So I'll be discussing so many important sections. Your reviews, you're right. Reaction of sodium hydroxide with HCl. That is base with acid, exo. Dissolution of bases in water, exo. Dissolution of acid in water, exo. Now, by now you know the answer, but there is something to learn. Remember, ammonium chloride dissolution, on, endo. Ammonium chloride dissolution is endo. Dissolving glucose in water, on, endo. Now you put some glucose in water, dissolvency, you can feel the system getting cooled down. You can feel your hand getting cooled down. Why? Heat is absorbed. So remember, dissolution of ammonium chloride in water, endo. Listen, ammonium chloride in water, endo. Glucose in water, endo. Urea in water, endo. Again, repeat louder. Ammonium chloride in water, endo. Glucose in water, endo. Urea in water, endo. Acid base, repeat louder. Acid base reaction, exo. Dissolution of bases, exo. Dissolution of acid, exo. Hurry, what is it? When I ask what is it, that means I'm asking whether things are there in the mind. More than doing the paper, what is important is you learn whatever the important points, put it to the mind. Things in the mind? Things in the mind? Hurry. Perfect. Those are writing reviews. If you can, at the end, if you write all the reviews, if you can send me the review, so I can forward group. So all of you to write your own review. Acid-base reaction, exo. Dissolution of bases, exo. Dissolution of acids, exo. Ammonium chloride in water, endo. Glucose in water, endo. Urea in water, endo. So answer is answer 3. They're asking endothermic. 21. Human system and diseases associated with them are given below. Please make it a point to go through the diseases together with the systems. When you go through the system, never ignore the diseases. Diseases play a major role. If you take your fifth essay question, mainly they ask from biological process of human body. When they ask from biological process of human body, surely they will touch the diseases. That's a section where you take marks from home. You take marks from home. Human system and diseases associated with them are given below. Urinary system, respiratory system, blood circulatory system, digestive system, thrombosis, typhoid, silicosis, nephritis. Select the correct order of diseases according to the given system. Don't panic. One by one go through. Urinary system. Thrombosis, typhoid, silicosis, nephritis. With the name you can understand. Nephrons are there in kidney. No? Nephritis should be there in what system? Urinary system. The urinary system, nephritis. Respiratory system. Respiratory system. Thrombosis, typhoid, silicosis. What's a disease? Silicosis. Silicosis associated with respiratory system. Blood circulatory system. Thrombosis. Digestive system, typhoid. DCAB. DCAB is answer number 3. DCAB, answer number 3. Now itself, if you can, together with the system, in your review note, together with the system, write the disease and key. Together with the systems, write the disease and key. Right. Equal concentration solution of the following compounds are given to you. Which one has the highest pH? Which one has the highest pH? Which one has the highest pH? Onnapute pH. Now almost for the third time or something I am explaining about this pH connection. Onnalamai pH. pH 0, 7, 14. 0, 7, 14. Small numbers are A. Big numbers are B. A for acid. B for base. Number 7, neutral. Small numbers A, big numbers B, A for acid, B for base. Number 7, neutral. Now, if you look at 0 to 14, 0 to 14, 0 to 14, this way, acid, neutral, base. Acid, neutral, base. That means basicity increase. Acid, neutral, base, basicity increase. On the other hand, acid is becoming neutral. It's going to base. Then acidity decrease. Basicity increase, acidity decrease. That's why acid is becoming acid, neutral, base. So acidity decrease, basicity increase. Now the question is asking, equal concentration solution of the following compounds are given to you. Which one has the highest pH? Highest pH. Highest pH should be base. What kind of base? Basicity is increasing. Weak base or strong base has a highest pH. Is increasing this way, then which one has a very high pH? Weak base or strong base? Strong base. Basicity is increasing. Basicity increasing means highest pH should be strong base. So now you need to find which one is strong base. Remember, in our syllabus, only 2 strong bases are there. What are the 2 strong bases? Chemnite I gave you. Sodium hydroxide, potassium hydroxide. What's the answer? Answer 1. Guaranteed strong base. Right. Question number 23. SI unit of specific heat capacity is. SI unit of specific heat capacity is. Now, when I tell specific heat capacity, if you have done Q equals MC theta equation type questions, if you have done Q equals MC theta equation type question, you know specific heat capacity, most of you, what is the unit coming into your mind is joules per kilogram per degree Celsius. This is a unit coming into most of your mind. Why? This is what you, from this unit only, you did so many questions. Joules per kilogram per degree Celsius. And that is 1 unit of specific heat capacity. Is it SI? SI means every single unit in should be SI. Is it SI? Is it SI? No. Why? Hari think joules is SI. Joules is the SI unit of energy. Kilogram is SI. Yes, kilogram is the SI unit of mass. But look at temperature. What's the SI unit of temperature? Kelvin. So your final unit should be in Kelvin. So this is not the SI unit of specific heat capacity. SI unit of specific heat capacity is joules per kilogram per, joules per kilogram per Kelvin. Joules per kilogram per Kelvin. That's the SI unit of specific heat capacity. That is answer number 4. Joules per kilogram per Kelvin. Answer is answer 4. Those are marking Dingala mark. Those are good mark. 20th question answer 3. 21 answer 3. 22 answer 1. 23 answer 4. Why can't be sulfuric acid be answer for 22nd? You all tell the answer. Why sulfuric is not the answer for the 22nd question? Why sulfuric is not? It's acid. Acid will have low pH, not high pH. High pH is base. That's also strong base. Sodium bicarbonate is a base, correct, but it's a weak base. Baking soda is a weak base. Sodium chloride is neutral. If you want, I'll write and keep there. This is strong acid. This is neutral. This is a base, but weak base. Question number 24. Superb question. Eh? Diagram shows light dependent resistor in a circuit. This can be used for. First, you should know the working principle of LDR. First, you should know the working principle of LDR. That is question 24. What's the working principle of LDR, Lamai? LDR, light dependent resistor. Its resistance value depends on the amount of light falling on it. Its resistance value depends on amount of light falling on it. No, that's why you do the light dependent resistor. Resistance value depends on its resistance value depends on the light. How? Remember, when the light intensity increases, when the intensity of light increases, resistance will decrease. When the resistance decreases, current flow will increase. Again, light intensity increase, resistance decrease, current increase. Vice versa. When the light intensity decrease, now opposite. Resistance will increase, current flow will decrease. Don't go to memorize both of these. If you go to memorize both of these, you will get confused. Only memorize one. When light intensity increase, resistance decrease, current flow increase. Even current flow, no need to memorize. Memorize resistance part and the light. Light increase, resistance decrease. Where repeat with me? Light increase, resistance decrease. Again, repeat with me. Light increase, resistance decrease. Current flow increase. That no need to memorize. Light increase, resistance decrease. Current flow increase. Don't go to even think of this. Don't go to even memorize it. From this, you can get this. If you try to memorize this, you will get confused. Now, that is where some things are there in science which are going in opposite connection. If you try to memorize both, sometimes in the exam you go confused. Now let's say you memorize both of these. In the exam, when you go and sit, you start getting confused by yourself, thinking light increase, resistance increase or decrease. That confusion will automatically start in your mind. So if there are opposite connections, only memorize one, other one don't even look at it. Then you know no, the other one is the opposite. Don't even look at it. So your brain knows what you have memorized very thoroughly is what is that. Then opposite is the other one. Use that logic. So light intensity increase, resistance will decrease. Current flow will increase. That's the connection. Now, diagram shows light dependent resistor in a circuit. This can be used for. This can be used for. Now, how will it work? When light intensity increase, that means during daytime, resistance decrease, current flow increase. When the current flow increases, what will happen to the bulb? What will happen to the bulb? Think. What will happen to the bulb? Bulb will light up. Now read the first statement. To switch on the lamp when daylight begins. Correct? No? During daytime, current increases, bulb will light up. See? During daytime, light is there. During daytime, light is there. Current will increase, bulb will light up. Daytime, resistance decrease, current will increase, bulb will light up. To switch on the lamp when daylight begins. Yes, this statement is correct. What are they asking? Correct statement or wrong statement? Correct statement. Second one, switch on the lamp when it begin to get dark. Wrong. No? During dark, get off. During darkness, during dark, when there is dark, light intensity decrease, current will reduce. If current reduces, it should get off. They are telling, switch on the lamp when it begin to get dark. Wrong. Not switch on. It should be switch off. To make the battery charge in sunlight, no, there is nothing like that. To make the lamp flash on and off, no, there's nothing like that. Answer should be answer one. Answer should be answer one. Okay. So remember the use of LDR. LDR, when light intensity increase, resistance will decrease, current will increase. That's the connection. When light intensity increase, resistance decrease, current will increase. I'll show the same circuit. There was a video on the same circuit. Cell, LDR, they are not using a bulb there, they are using a LED. Instead of this, you put a LED. I'll show that same circuit. Now, this is a LED. This is a real LED. Sorry, this is a LDR. This is the real LDR. Maybe you can't hear. That doesn't matter. Now LDR is there. It is connected to the LED. LED is there. From there, they are connecting to a cell. So it's the exact same circuit. Here they are using LED, LED, LDR, and the cell. See, cell is there, LDR is there, LED is there. Now the LED is lighting up. LDR is receiving light, light is there, LED is lighting up. Now see, when he presses, it becomes dark, this also goes off. When there is light, it lights up. Now you all watch the full video again. One more time watch. Understood. So remember, when there is light only, it lights up. When there is no light, when he presses it with the hand, when he makes it dark, it goes off. That's a condition. That's how it works. I saw some of your questions, sir. Then what's the use of it? Oh, at night only we need light. At night it's going off. When he keeps the hand, it went off. At night it is going off. Night only we need light. Night it is going off. Daytime we don't need light. It's switching on. Remember, LDR is just a sensor. This is not the circuit we make. This is not the final circuit we make. LDR is just a sensor. It is used to sense the presence of light. If there is light, it will give an output with a high current. If there is no light, output no. Maybe you can convert it into binary forms. If there is light, LDR will give an output 1. If there is no light, LDR will give the output 0. So if you get 1 as the output, that means light is there. If you get 0 as the output, light is not there. It's just a sensor. After this, you need to make a separate circuit. If 1 comes as the output, light is there. Then what is your next work? If 0 comes as the output, then hurry, light is not there. Then what is your next work? So that decision should be taken separately using a separate circuit. This is just a sensor circuit. This will just give the input signal. From that, you again convert it into some other programming part. That's how it works. Usually now phones also have LDR. At the top there, most of the phones at the top there, near the camera, you can see LDR. There's LDR. That is why they have invented a new feature called automatic brightness adjusting feature. Have you seen? Automatic brightness adjusting feature. Now you take the phone and go in bright sunlight, then automatically the brightness increases. Now see, this one, I have set it to lowest brightness. I set it to lowest brightness. Now it is very bright here, automatically the brightness increases. See, slowly the brightness is increasing. It increases according to the amount of light. It automatically increases and goes up. If I show it to a very bright, this thing automatically goes up. See? That's because of LDR. So separately you should have a setup. Separately you should have a setup to make the brightness to go up. So that's the function of LDR. And now I explain everything about LDR. Hurry. Question number 25. So remember, in this one, at least remember that video will you, when he presses the LDR, when he touches the LDR, it becomes dark. LED also goes off. When he removes the hand, it becomes bright. The bulb also comes on. In which instance, question 25, in which instance object is OR at equilibrium? At which instance object is at equilibrium? What's the condition? For the object to be at equilibrium, final resultant force should be 0, number 1. and there should be no any moment. Final result also should be 0. If there is moment, it will start rotating. There should be no rotation, no resultant force. A, left 10 Newton, right 10 Newton. What's the resultant? What's the resultant? One shot, tell me. This side 10 Newton, this side 10 Newton. 0. Will it rotate? Either. Forces are in the same line of action. Can it rotate? No. No rotation, no resultant. Again, it's at equilibrium. B, 10 Newton to the right, 10 Newton to the left. One shot, tell me what's the resultant? 0. Resultant is 0. Plus, both the line of action are in the same line. Then will there be any rotation? No rotation. Resultant is 0, no rotation, it's at equilibrium. Next one. 10 to the left, 10 to the left. Both are towards the left. What's the resultant? 20 to the left. Will it go? Yes. It will have a small, it will have an acceleration towards the left side. So it's not at equilibrium. A and B are at equilibrium. Answer is answer 1. Question 26. A circuit is shown below. Which of the following represent the measurement displayed by meter 1 and meter 2? When you look at the connection itself, you should be able to understand what is that meter. Onnalamai. You all tell me. Ammeter is connected in what connection? Meter connection. Dingala, tell me. Series connection in the same line. Ammeter should be in series connection. Ammeter series connection. Voltmeter. Voltmeter should be connected in parallel connection. Perfect. Ammeter series, voltmeter parallel. Now look at this. Can you see meter 1 is in series? This means in the same line. Meter 1 is in series. Ehinang tell me meter 1 should be guaranteed what? It's in series. One is what? Ammeter. Meter 2, it's in parallel connection with the bulb. Then meter 2 is what? Guaranteed voltmeter. Look at the answers. This is the following represent the measurement displayed by the meter 1 and 2 respectively. 1 and 2 respectively. 1 and 2 respectively. So first is meter 1. First answer, voltage. Wrong, no. Meter 1 will measure current flow. Meter 1 is ammeter. Ammeter will measure current flow. From there itself, you can tell first answer is wrong. Second answer. Voltage. Again, wrong. Meter 1 is ammeter. Ammeter measures current flow. So voltage. Pachappoi. For the second answer, wrong. Third one. Current in the resistor. Fourth one. Current in the lamp. So third and fourth can be your option. 50-50. Now we'll go through third and fourth. Third, current in the resistor. Ammeter is used to measure current in the resistor. Remember, using this ammeter, you can measure the current flowing in that same line. Whatever the current flowing here is the current flowing there. Whatever the current flowing there is the current flowing there. That's the same current flowing there. That's the same current going through the resistor. That's the same current going through the bulb. So it's the same current flowing through all these. So using ammeter, you can measure the current through the resistor as well as the bulb. Don't think resistor, a different current will go. Bulb, another different current will go. Wrong. Same line, same current will flow. Same line, same current. Meter, if you look at the connection, in that same line, you have the resistor and the bulb. So same line, resistor and bulb are there, same current will go. So using the ammeter, you can measure the current flowing through the resistor as well as the current flowing through the bulb. Both the reading, one shot you can get. That means overall current flow you can measure. So here they are specifically telling current in the resistor. Hari pulu, you can. And voltage across the lamp. Hari ne. Voltmeter. Now using voltmeter. Voltmeter is specific. Voltmeter, you can't measure the overall thing here according to the connection. Using voltmeter, only what voltage you can measure? Only what voltage you can measure? Bulb's voltage, lamp's voltage. Only this voltage you can measure. It's parallelly connected between the terminals of the bulb. So only bulb's voltage you can measure. Using ammeter here, you can measure the overall current flow. Using the voltmeter here, you can only measure the voltage between bulb and bulb. So current in the resistor and voltage across the lamp is correct answer. Third one is correct. Just go through the fourth one. We'll see why fourth one is wrong. Current lamp, yes, you can. And voltage across battery. You all tell me, can the voltmeter here measure the voltage in the battery? No. To measure the voltage in battery, then you need to connect it parallel to the battery. If you connect it this way, then you can measure the voltage in battery. It's not connected there, it's connected here. This is only restricted to the voltage in the bulb. Only you can measure the voltage in the bulb, not the battery. So guaranteed fourth answer is wrong. Understand why things are wrong and why things are correct. Answer is answer 3. 27. Okay, got it. Got it. What would happen when the voltmeter is placed on the place of ammeter? That's a question. What would happen when the voltmeter is placed on the place of ammeter? It will not measure anything. It will not measure anything. You connect the voltmeter at the ammeter's location. Voltmeter will not give anything. If it is a digital voltmeter, it will show error. Because voltmeter should be connected in series connection. Explain the voltage part again. Okay, right. See, voltmeter is connected parallel to the bulb, only parallel to the bulb. So it can measure potential difference across the bulb only. Only bulb's potential difference it can measure. Now, by connecting the voltmeter here, can you measure the potential difference in the resistor? This one's can you measure? No. If you want to measure the potential difference across the resistor, then you need to connect the voltmeter like this. If you want to measure the potential difference across the battery connection there, then you have to connect the voltmeter like this. What you are measuring, you connect it. So voltmeter is specific. So voltmeter should be connected. If it is connected like this, that means you're only measuring the lamp's voltage, not the resistor's voltage. Fourth one is telling, using that voltmeter, you can measure voltage across the battery. Wrong. Simple question. Simple question. Simple question. You all answer me, eh? You all answer me. You are at your home. This is your house. You're at your house. While you are at your house, can you tell what is happening in your school? When you are in your house, now let's take now at this moment. Now what's the time? 11:45 or something. Some thief has got into your school. Just imagine. Eh? While you are at home, no CCTV. While you are at home, can you tell what is happening in your school? No. That you can't tell. For that, you need to go there. Same thing. Voltmeter is connected between the terminals of the bulb. So it is only restricted to whatever happening in the bulb, not what is happening in the battery. If you want to know what is happening in the battery, you need to connect it to the battery. Understood the person who asked it. Okay. Huh. So that way fourth answer is wrong. These things understand and underline. Don't guess and underline. 27. Some properties of compounds are given below. Aqueous solution conduct electricity. The moment you hear it, you should know they are talking about ionic compounds. Most of the compounds are soluble in water, mostly exist as molecules made of several atoms. Out of ABC, properties seen in ionic compounds are right. Aqueous solution conduct electricity. Of course, it is a property of ionic compound. B, most of the compounds are soluble in water. Of course, yes, most of the ionic compounds are soluble in water. Sodium chloride, soluble in water. Magnesium chloride, soluble in water. Most of the ionic compounds, of course, yes, soluble in water. Mostly exist as molecules made of several atoms. This is for what compound? Exist as molecules made of several atoms. Is it ionic or covalent compound? It's for covalent compound. Keep that in mind. In your part 1 book, grade 10 science part 1 book, under bonding lesson, last page there you have the properties of ionic compounds and covalent compounds. Properties of covalent compounds, read the first sentence. Exactly this sentence is there. So this is property of a covalent compound. C is wrong. So ionic properties are A and B. A and B is answer 1. The diameter of the trunk of a jack tree increases with its growth. The activity of which one of the following tissue is responsible for this? When you hear the word diameter is increasing, what type of meristematic tissue should come into your mind? The moment you hear diameter is increasing, which meristematic tissue should? I'm asking meristematic tissue. Don't look at that. I'm asking the question, which meristematic tissue should come into your mind? And lateral meristematic tissue. Tell me an example for lateral meristematic tissue. Tell me an example for meristematic tissue. Cambium tissue. Cambium tissue. So they are asking the diameter of the trunk of jack tree is increasing with its growth due to what tissue? Cambium tissue. Cambium tissue. Question 29. A transformer with 1000 turns in primary coil and 100 turns in secondary coil is used in the power transmission. If the primary voltage is 2300 volt of AC is supplied, what would be the type of transformer and output voltage? Right, we'll write those numbers and the value. 1000 turns in primary, 100 turns in secondary. Onnala, my transformer is there. 1000 turns in primary, 100 turns in secondary. Primary 1000 turns are there, secondary 100 turns are there. And they are telling primary voltage is 2300 volt. 1000 turns in primary, 100 turns in secondary. Number of turns are decreasing. Step up or step down? Step up or step down? And right. Step down transfer. Moment you hear 1000 turns in primary, 100 turns in secondary, number of turns in primary is more than secondary, that is step down. So guaranteed this is step down. And they are asking, what's the voltage in secondary? What's the voltage in secondary? Number of turns are given, voltage in primary is given, voltage in secondary they are asking. What's the one and only equation that connects number of turns and voltage in a transformer? What's the one and only equation that connects number of turns and voltage in a transformer? Number of turns in primary divided by number of turns in secondary is equal to voltage in primary divided by voltage in secondary. NP over N is equal VP over VS. Number of turns in primary, you know, 1000 divided by. Number of turns in secondary also, you know, 100 equal. Voltage in primary given 2300 volt. Voltage in secondary, you have to find Vs. Now maths. If you need to find Vs, you need to subject Vs. Subject Vs, get the final answer. Now maths. If I subject Vs, Vs goes on top. Vs is equal to 2300. This denominator 100 goes to the other side, multiplication 100. Numerator 1000 on the other side become division 1000 volt. Vs is equal to 000 1 2 000 cancel off. 23 into 10, 23 into 10, that gives you 230 watt. 230 watt AC current. Step down transformer 230 watt. That is answer number. Where you have 230 volt? 4. Answer number 4. Those who want the calculation, right? The reason for releasing support seminar. Reason is very direct. You do that paper. That's it. Don't think anything else. Don't think, this is guest paper. These questions will come there, giving us a hint. Why would the government give you a hint? Is this a, what you call, inning game or anything to give you a hint? No. Don't think anything like that. It's a paper. You practice. Nothing beyond that. No hints, nothing. Plus, this is not the official support seminar. Official support seminar has not come for your batch. Ha! 30th one. So, won't we get it? I can't answer that question in a public this thing. Where did I put the pen? Right. Question 30. The addition of which of the following metal to zinc chloride would cause the formation of precipitate? Addition of which of the following metal to zinc chloride would cause formation of a precipitate? Nicely, they have dressed the question. That is what I have to tell. 30th question. Question is very simple. Only thing is they have dressed the question very well. They are asking which of the following, when you put, you can see a formation of precipitate. So zinc chloride. Zinc chloride, you are adding something. I'll name it as metal M. Once when you add it, for the formation of precipitate lamai, this M should join with chlorine. Just tell whether the logic is correct. For the formation, not only precipitate, for the formation of anything, that whatever we add should join with chlorine, right? Think whether the logic is correct. Not only precipitate, whatever we add should form a precipitate, should join with chlorine. For it to join with chlorine, it should be able to displace zinc. Whatever that joins should be able to displace zinc. Zinc should come out. Then only whatever the precipitate, whatever that has to be formed will be formed. Unless and otherwise, can a precipitate be formed? without removing the zinc? So now think. Whatever you add should be able to displace zinc. Ehenan tell me the one that you are adding should be above zinc in the activity series or below zinc. It should be able to displace zinc now. It should be above zinc or below. Above zinc. So the question is very, very simple. What's the metal that can displace zinc? Or if I make the question more simpler, more and more simpler, which of the following metal is more reactive than zinc? On answer the question. Which of the following metal is more reactive than zinc? Which of the following metal is reactive than zinc? One answer. What's that? Magnesium. One and only answer is magnesium. So you can see the basic logic is very simple. What they have done is they have nicely dressed the question. What they do in the paper, Lamai. That's what when we set the papers, we do. Logics in science are very simple, very basic. Only now, you let's say you are a student of 1950, and you are a 1950, and you are a student of 2000, you are a student of 2025. Whatever the year you write the paper, in science are same. Just think. Logics in are same. Whatever logic, whatever the basic logics we have, it's the same. So whatever the year we make the paper, logics are the same. Whatever the base there is the same. What we do is we just dress the question. We just cover the question such that you can't find the logic. So your job is to break it and find the logic there. If you find the logic, you can answer it. Any question is like that. Essay questions and all. Sometimes you'll see very big pictures are given, big diagrams are given, big graphs are given. Why? Those are the dressing. That is to dress the logic there. We give big diagrams and all. That is exactly to dress the question. So once when you all see big diagram, big graphs and all, 2, 3 graphs in the same plot and all, then you go fully upset no once you see such a question. And at that moment, examiner wins, you lose. Don't know that. You break it and see what's the basic logic there. You know logic. You have studied science for 2 years. Don't tell you don't know the logic. You were in the classroom. You were in the school. You have touched the textbook. You have gone through the logic at least one single time. You know the logic. So your job is to find out the logic. Answer it. It's like treasure hunt. Doing the paper is just like treasure hunt. 31. Which of the following is incorrect about liquid pressure? Incorrect about liquid pressure. Now, what you know about liquid pressure? Now, once you get a question like this, first scan the logic. In your brain, scan the logic. Hurry, liquid pressure. What do you know about liquid pressure? Liquid pressure, hydrostatic pressure is equal to H rho G. That you know. So first scan that logic, fix that logic in your mind. Now see how they are dressing. Now see how they are dressing. Which of the following is incorrect? Incorrect about liquid pressure. Liquid pressure depends on the depth of the liquid. Of course, yes. It depends on the depth. 2. Liquid pressure depends on the density of the liquid. Of course, yes. It depends on the density of the liquid. Liquid pressure depends on the shape of the container. Now, am I adding anything about shape of the container here? Is there any about the container in the equation? Remember, hydrostatic pressure does not depend on the shape of the container. It's a basic logic. That's wrong. Liquid pressure depends on the gravitational acceleration, of course, yes. So which one is incorrect? Answer is answer 3. Someone asked me to show the 30th one answer. 30th one, magnesium. Answer 4. 32. The graph shows two waves, X and Y, correspond to a source of sound in these two waves. First, look at the graph. What they are trying to tell you from this graph. First, analyze the graph. There is a wave called Y. It's going like that. There's a wave called X. It's going like this. What is common about X and Y? Can you see Their wavelengths are the same. Wavelengths are same. Next, number of waves that are taking place in a given time is the same. Number of waves occurring in a given time is the same. See, y. Let's take to finish one wave of y, it takes 1 second. To finish off one wave of x also 1 second. Let's take y. To finish off two waves of y, it takes 2 seconds. To complete two waves of x also, it takes 2 seconds. So number of waves occurring in a given time is the same. Lama, you all tell me, number of waves per unit time, what is that? Number of waves per unit time, what is that? Frequency. Then I can tell frequency also same. Frequency same. Wavelength same. Next, if frequency is same, what can you tell about the pitch? That is also same. Pitch is also same. Because pitch depends on frequency. But look at the amplitude. X amplitude, Y amplitude. Who has a greater amplitude? Y has a greater amplitude. That means amplitudes are not same. I'll write it as A. A is not same. It is different. We already know loudness depends on the amplitude. If amplitude is different, what can you tell about the loudness? That's also different. If loudness is different, what can you tell about the energy level? What can you tell about the energy level? Of course, now if I talk louder, that means I am giving out lot of energy. When I talk louder, I feel myself tired. Why? The more louder I talk, the more energy I have to give. More softer I talk, less energy I have to give. To create a loud sound, you need to give a big energy. So louder the sound, greater, softer the less. So if loudness is different, guaranteed energy also different. If you want, you talk and see. If you want to talk louder, you need to give a lot of energy. If you want to talk softer, you give a little bit of energy. So if the loudness is different, guaranteed energy is different. Now go to the question. The graph shows two waves x and y correspond to a source of sound. In these two waves, frequencies are equal. Of course, yes. Frequencies are equal. Amplitudes are equal. On the amplitude equal, it seems. Loudness is equal, no? If amplitude is not equal, loudness cannot be equal. Energies are equal, no? Energy is not equal. Answer is answer 1, frequency. Third three. The graph shows the variation of temperature when heating solid wax. Question number 33 and 34 are based on the graph given below. Again, see, graph shows the variation of temperature when heating solid wax. So your starting stage is solid wax. Your starting stage is solid wax, right? We'll analyze the graph first. We'll analyze the graph. Your starting stage is solid wax. Your start is solid wax. Slowly you are increasing the temperature. Slowly you are increasing the temperature. That means solid wax temperature also increase. Solid wax temperature also increase. It comes to this point. Still it is solid wax. When we heat solid wax, quickly it will melt. Quickly, but in between there is a small timing. So until that timing, it is still solid. So solid wax, you heat it until it comes to the melting point, it is still solid. On. Now it has come to the melting point. At the melting point, solid wax will convert into liquid wax. State is changing. Y'all tell me, during a state change, will there be any temperature change? Is there any temperature change during state change? No, never. Remember, when the state is changing, there is no temperature change. Solid wax is converting into liquid wax. Melting is happening. Melting point is a constant temperature. Melting point is not a variable temperature. Melting point of water is 0 degrees Celsius. When I ask for melting point of water, you don't tell any different values. No? It's a constant temperature, 0 degrees Celsius. Same way, wax, any substance, melting temperature is a constant temperature on. It's a constant temperature. Until all the solid turns into liquid, temperature remains the same. Temperature is constant. No change to the temperature. That's why you have a flat graph. Remember, in temperature versus time graph, the moment you see a flat graph, that means there's a state change. Again, I repeat, temperature versus time graph, the moment you see a flat line, that means there's a state change. Maybe melting, maybe vaporization, anything, there is a state change. Flat line tells us a state change because temperature is not changing, temperature is constant. So here state change is happening, melting is happening. During state change, the amount of heat you give a special name to that. What is the special name given? What's the special name given to the heat supplied during a state change? What's the special name given to the heat supplied? What's the special name given to the heat supplied during a state change? Look at the question. Look at the question and answer. What's the special name given to the heat supplied during a state change? Latent heat. Latent heat. Now, I be specific. What's the special name given to the heat given during melting? During melting. What's the special name given? Latent heat of fusion. So during melting, you give latent heat of fusion. So whatever the heat given is latent heat of fusion. Again, once when all the solid wax converts to liquid, slowly it will convert. All solid slowly melt and convert to liquid. Once when all of them convert to liquid, again, now liquid. Liquid's temperature is increasing. So always remember, temperature versus time graph. The moment you see a flat line, that means state is changing. At that time, temperature does not change. At that time, whatever the heat you give is latent heat. If it is fusion. If it is vaporization, it's vaporization. What is called to the heat supply during this time interval? What time interval? Even when continuously heated, no change in the temperature observed between B and C. Of course, yes, no change in the temperature. What is called the heat supply during this time interval? What is the special name given? Latent heat of fusion. Now that direct answer is not there, but you can see latent heat of melting. Yes, that can be the answer. So your answer is latent heat of melting. Okay. Why can't be vaporization? Now, why can't it be latent heat of vaporization? You all tell me. Why can't it be latent heat of vaporization? Because they are telling your starting stage is solid. So first flat line should be melting. Without melting, how can you go to vaporization? You start from solid. Guaranteed the first flat line should be melting. If you have another flat line, let's take somewhere here. Then tell me, what is that? The heat given there is what heat? The heat supplied there is what heat? Now you can tell latent heat of vaporization. Second flat line can be vaporization because your starting stage is solid. First flat line is guaranteed melting or fusion. Right. So analyze the graph when you do. Question number 34. Physical state of states of wax between B and C. Between B and C. What are the physical states possible? Solid is there, liquid is there. So both those states are possible. During this time slot, don't think solid will at once become a liquid. For example, you take ice, when the ice is melting, you can see solid ice as well as liquid water. Solid ice as well as liquid water. So during a state change, you can see both the states until the full substance is converted into the other state. So during BC, solid is also there, liquid is also there. Both the states are possible. So BC, both liquid and solid answer is answer 2. $35. Why high voltage, hurry, and low current used to transmit energy over long distance? Now this one theory class students I taught you all under transformer section. When transmitting electricity, why you try to reduce the current flow? What's the reason? What's the main reason to reduce current flow? Remember, from the national power grid, you need to supply current to very long distances. Different provinces, different very long distances, you have to supply current. Using what we are going to supply current? How we are going to supply current? What's the methodology used in Sri Lanka to supply current? Using wires. Using wires, you are transmitting current to long distances. Small wires, comparatively small wires. Using these wires, you are transmitting current to very long distances. Just imagine, if you send large current through these wires, small wires, if you send large current, what will happen in the wire? Wire gets heated. Surely wire will get heat. If so, you will be losing energy as heat. It's a loss, no? Whatever the way you lose electricity, it's a loss. So if you try to send large current through these wires will get heat loss. Then you all tell me, you send large current through the wires or small current? Large current through wires or current? Small current. You send small current through the wires. Why? Then the heat loss will be less. Heat loss is less. To reduce the heat loss, only you send small current. What's the answer? To reduce heat loss from the power lines. Answer is answer. Hmm. 36. Decomposition reaction of calcium carbonate is given below. Mass of calcium oxide produced by decomposing 200 grams of calcium carbonate is. Hurry. Can you all remember our 2019 paper, second set of MCQ, where I discussed about potassium permanganate decomposition? I talked about stoichiometry. This is that type of question. They are telling 200 grams of calcium carbonate is decomposed. Mass of calcium carbonate is given 200 grams. Right. Now, what is our stoichiometry telling? Last week work, last class work. What is stoichiometry telling? What is the ratio concept telling? See, once when you balance a certain chemical equation, this is balanced, already balanced. Now, if there is no number in front, that means number one is there in front. If there's no number, one is there in front. That's the meaning. No number can one is there. Now, what does this balanced chemical equation telling us? 1 mole of calcium carbonate, one is there in front. 1 mole of calcium carbonate decomposed to form 1 mole of calcium oxide, one is there in front, and 1 mole of carbon dioxide. That's the meaning. 1 mole of calcium carbonate decomposed to form 1 mole of calcium oxide, 1 mole of carbon dioxide. 1, 1, 1. In front you have 1. 1 mole decomposed to form 1 mole and 1 mole. That is what I taught. Did I teach all when 200 gram decompose, the same ratio will be there? Did I teach something like that? No. The ratio is between the moles. 1 mole decomposed to form 1 mole and 1 mole. Now the question is telling 200 grams of calcium carbonate is decomposing. 200 grams mass is given. First we will convert that mass into moles. 200 grams of calcium carbonate. How many moles of calcium carbonate are there? Work it out. Number of moles is equal to mass over molar mass. Mass is 200 grams. Molar mass, now, usually my paper students, my theory class students, I have told you to memorize the molar mass of calcium carbonate. A repeated type of question comes. What's the molar mass of calcium carbonate? Memorize it. Keep 100. If you want, you do it and fine. But no need to no need to waste time in finding it. Calcium 40, carbon 12, oxygen 16 into 3. You do the math there, you get 100. 100 gram per mole. Huh. From there, you know the number of moles. What's the number of moles? 2 moles. Now you know the number of moles of calcium carbonate. What are they asking? What are they asking? Decomposition reaction of calcium carbonate is given below. Mass of calcium oxide produced. Mass of calcium oxide produced when 200 grams of calcium carbonate decomposed. Mass of calcium oxide. Leave the mass story aside. We already know when 1 mole of calcium carbonate decompose, 1 mole of calcium oxide will be produced. 1 mole decompose, 1 mole produce. Ehenang, you tell me when 2 moles decompose, how many moles of calcium oxide will be produced? 1 mole decompose, one mole is produced. Then 2 moles decompose. How many moles will be produced? And right, 2 moles are produced. Number of moles, 2 moles. They don't want the number of moles. What they want? They want the mass of calcium oxide, mass of calcium oxide. Right. Calcium oxide, calcium 40, oxygen 16, 40 plus 16, 56 gram per mole. Molar mass, you know. Molar mass, you know. 56 gram per mole. Ehenang, you all tell me what's the mass? Number of moles are there, mass, molar mass is there, can't you find the mass? Find the mass. Number of moles are there. Now this is grade 10 question. Number of moles are there, molar mass is there, find the mass. Basic equation, number of moles is equal to mass over molar mass. You need to find mass. Mass is equal to number of moles into molar mass. Number of moles is there, 2 moles. Molar mass is there, 56 gram per mole. Do the math there. 2 into 56 is 112 grams. 112. Okay. So your mass is 112 grams. That's the answer. Answer number 4. Those who want the calculation, right? I'll keep it to the side. Those who want, right and give. So remember the connection. After balance chemical equation, moles, you can build a connection. Moles, you can build a connection. If they give mass, then you find the moles. From there, you connect and find the mass. Huh. Question 37. Question 37. 4 chemical reactions are given below. Thermal decomposition of potassium permanganate. Decomposition of hydrogen peroxide. Thermal decomposition of calcium carbonate. Electrolysis of water. Right. In which of the above instances is oxygen released as product? We'll write the products. We'll write the product gases. We'll write their product gases. Thermal decomposition of potassium permanganate. That's the most ideal method we use to produce oxygen in lab. It's a method of producing oxygen in lab. It releases oxygen gas. Decomposition of hydrogen peroxide. Hydrogen peroxide decomposition releases water and oxygen. Water and oxygen on oxygen release. Thermal decomposition of calcium carbonate. Not only calcium carbonate, any carbon, if you decompose, it will release carbon dioxide. Keep that in mind. Carbonates releases carbon dioxide. Carbonates releases carbon dioxide. Keep that in mind. Carbonates release carbon dioxide. Electrolysis of water. Chem night we did know. Tell me electrolysis of water. What are the two gases? What are the two gases? Hydrogen and oxygen. Both hydrogen and oxygen are released. Which one highest amount? Which gas highest amount during electrolysis of water? Hydrogen. 2 times the volume of oxygen. Those points keep in mind. Now, in which of the above instances oxygen liberated? A, yes, B, yes, D, yes. A, B, D. Answer is answer 2. Right. 38. Which answer includes, the correct group which contain greenhouse gases. Greenhouse gas, right. First one, carbon dioxide, yes, greenhouse gas. Argon, is argon a greenhouse gas? No. I'll tell why no. Each and every answer, I'll tell the no's. Argon is not a greenhouse gas. Chlorofluorocarbon, yes. Methane, yes. So argon is not a greenhouse gas. Answer 1 is wrong. Second, carbon dioxide, of course, a greenhouse gas. Oxygen. Is oxygen a greenhouse gas? Nope. Chlorofluorocarbon, yes. Methane, yes. However, second one wrong. Third, carbon dioxide greenhouse gas, methane greenhouse gas, chlorofluorocarbon greenhouse gas. Is hydrogen a greenhouse gas? No. Hydrogen is not a greenhouse gas. Therefore, third one also wrong. Fourth one, carbon dioxide greenhouse, methane greenhouse, chlorofluorocarbon greenhouse, water in gaseous form. That is water vapor greenhouse. That is correct. Which answer includes ions or molecules which cannot be present in a aqueous solution of HCl? Lemma, HCl is a strong acid. HCl is a strong acid. HCl is a strong acid. What will strong acids do in aqueous medium? What will strong acids do in aqueous medium? They undergo complete ionization. Complete ionization means they fully break down and form H plus aqueous and Cl minus aqueous. Fully broken. Fully broken. Arrow is fully going that side. Fully broken now, will you have full HCl molecule? Once when HCl is fully broken, will you have full HCl molecule? Nope. Full HCl will not be there because it's broken, fully broken, complete ionization. Meanwhile, remember when acid undergoes ionization in aqueous medium has water. Together with acid, water will also undergo ionization. Not complete, incomplete. Water undergoes incomplete ionization. It goes forward as well as it comes backwards. Water ionizes forward, forming H plus, OH minus, as well as it comes backwards, forming water. Again, forward H plus OH minus, backwards water. That means it's not fully broken. You have water, full water is there. H plus is there. OH minus is there. When HCl aqueous undergoes ionization, full HCl is broken, H plus is there, Cl minus is there. Water is not fully broken, H plus is there, OH minus, water is there. Then what are the ions and molecules that are present in aqueous solution of HCl? Full water, H plus, Cl minus, OH minus. H plus is there from HCl and from water. Cl minus is there from HCl. Again, no need to write H plus, no. OH minus is there from HCl, sorry, from water, and full water is there. H2O is there. These are the ions and will you have full HCl? Will you have full complete HCl? No, it's broken. It's broken. Fully broken. Once when you break something, again you can't have full form of it. So full HCl is not there. Which answer includes ions and molecules which cannot be present in an aqueous solution of HCl? H plus and OH minus are there, of course. H plus and OH minus are there. See, H plus is there, OH minus is there. Out of H plus and OH minus, which one has the highest concentration? Tell me. In acidic medium, H plus is there, OH minus is there, both are there. Which one has the highest concentration? And highest concentration is H plus. Highest concentration is H plus. See, both are releasing H plus. Both are releasing H plus. H plus is the highest concentration. However, H plus is there, OH minus is there, of course. H plus Cl minus, is it there? H plus is there, Cl minus is there. Yes. H plus Cl minus is there. Full water, OH minus. Full water, OH minus. Full water, yes, we have. OH minus, yes, we have. Full water, OH minus is also there. Full HCl, onna puthe, tell me. Complete ionization. Do we have full HCl? Do we have complete HCl molecule? Is a complete HCl molecule? HCl is fully broken. So you can't have HCl again. HCl is no more there. This is wrong. What's this answer? 40th question. Which of the following process causes ill effects such as melting of polar ice caps. When you hear the word melting, you should know. Thermal expansion of seawater, change of climatic pattern. What should we answer? Hmm? Melting of ice, all those things. Global warming. Answer. Huh? Send me your marks for the last 20 questions. Out of 20, how much? Out of 20. Good, good, good. 30th one, 38th one, 38th one. Answer 4. Good, good. Okay, no? 39th one, you want again. 39th one, what are they asking? Which iron no molecule cannot be there? Now you tell me. HCl, strong acid. Strong acid undergoes complete ionization. Complete ionization means completely broken. This remote, if I completely break it, will I have the remote on hand? If I completely break it, will I have the remote on hand? Full remote won't be there. But will I have pieces of this remote? Will I have pieces of the remote? Pieces of the remote will be. So remember, strong acid undergoes complete ionization, completely broken. Only pieces are there. Full is not there. But water not like that. Water undergoes incomplete ionization. I nicely remove this. I remove it. I remove. Again I fix. I remove. Again I fix. I remove. Again I fix. Then do I have complete remote on hand? Yes. Do I have the remote part on hand? Yes. Complete part is also, remote part is also there. That is incomplete ionization. So full water is there, H plus is there, OH minus is there. Again H plus from the HCl is there, Cl minus is there. Full HCl is not there. Remote is fully broken. The person who asked understood. So full HCl cannot be there in that solution. Okay. Hurry, Nate. Hurry, Hina. Tomorrow again we won't have. Tomorrow again we won't have. Tomorrow my goal schedule. Again Thursday we'll finish off this paper. Yesterday I couldn't do because yesterday after the Vattala class I had to go out to Colombo. Came home late night. In the yesterday night I couldn't do. Tomorrow no. Again I'll meet you on Thursday. Right? Thursday. Finish off this paper. The remaining the first 20 MCQs. That is only remaining. First 20 MCQs we'll discuss on Thursday and finish off. And after that, again we'll go to the 2019 paper. Where whatever the place where we stopped. Right? From there we'll continue. Hurry. Keep working. Keep working. Right? Days are running, yes, right? Small time slot is there, but a time slot where you can make a big changes. Time slot where you have a big change is there. That is there on your hand. Don't give up. Work. Keep working hard. Don't give up. Don't waste a single minute. Don't give up until the end. Keep on working. All of you can. All of you are staying this long, staying on something, and you all have something to learn. You all wanted something into your brain. That is why you're sitting. Don't allow that to just get wasted. Keep working. If phone is distracting, switch off the phone and put it inside the cupboard when you're studying. Don't think of that. If something else is disturbing, then for now don't have it. Whatever those that is disturbing, just get away from it. It's your time slot. Whatever the changes you do now, Whatever the small alternations that you do now will deviate your full life. Very sensitive stage. So be careful on what you select, what you do these days. Alright, I mean it. I'll meet you all again Thursday. Keep working.